Okay, and this question, this is 1B from your from 2.4. This is number 1B. And how do we do the product rule? Well, again, two ways. Let's take a look at method 1. And the product rule is method 2. Okay. Method 1, now you can do method 1 on these simple ones because it's easy to expand. Alright, so method 1 means you expand this out, and so f of x really is 3x squared minus 8x, right? When you take the derivative, that's when you put your little prime notation there, because now I'm taking the derivative, and I use my power rule, 6x minus 8. And that's the derivative of f of x. Product rule, remember, product rule is going to be looking like this. So if we identify this one as our first function f and this one as our second function g, then the product rule is going to be the derivative of x times 3x minus 8. And you don't have to show all this work once you get used to it. I'm just still explaining this to you, so you don't have to show all this work all the time, but plus, right, the first, which is x, times the derivative of the second. So take the derivative of the first times the second plus the first times the derivative of the second. And this is gonna get real quick for you. Okay, the derivative of x is what? 1 times 3x minus 8. So x times, now what's the derivative of 3x minus 8? What is it?
3.
3. It's just 3, yeah. This would be 3 plus or minus 0, right? So 3. So this is 3x minus 8 plus 3x. That's 6x minus 8. Okay? Now I know what you're saying. Method 1 is so easy. Why do I do method 2? Well, because this is easy to expand. And it comes out to a nice, neat little polynomial. But as you'll see, let's do another question. And it's not going to be so easy. Let's see. For example, let us do... let's do this one. Oh, shoot. I didn't get the 4. Oh, missed it again. Okay. There's a bee in the room? Oh, relax. It's not going to kill you. If it comes near me, I'll kill it for you. If it doesn't come near me, it'll probably bite you. And you might die. Okay, so watch this. See, look at this right here. Not going to be as easy to just expand and do the polynomial, right? You're going to be doing a lot of extra work here. So to find out what the derivative of g of y is, so g prime y, it says 1h. The derivative of the first, so there's the first. What's the derivative of the first? Let's just kind of skip that first step now. What's the derivative of this? Now remember, with respect to y, so this is our variable. What's the derivative of just the variable? 1 minus what? What's this? 2y. Very good. So the derivative of the first times the second. So you're just going to rewrite the second. Don't touch it. Don't take the derivative yet. Plus the first, so just the plain old first, not the derivative, just the plain old first times the derivative of the second. So, oh, whoops. So what's the derivative of 2y? 2. 2. What's the derivative of y to the power of 4 over 3? Bring this exponent down. So that's 4 over 3. It's a 4 over 3. Y to the power of what?
1 over 3.
Yeah. To the power of 1 over 3. Why is that? Because 4 over 3 minus 3 over 3 is 1 over 3. Right? Okay. So this is taking the derivative, and this is without simplification. All right? So notice in your textbook it says do not simplify your answer, which is good for you. Because there would be a little bit of a process of simplifying here, wouldn't there be? You'd have to multiply all this out and it'd be kind of tough. So this is your answer when it says do not simplify. You just do the product rule and then leave it. Okay? So this is not simplified. But that's what the question says. And if we go back there, the question just says use the product rule to differentiate, to find the derivative. Do not simplify. A little note here. When the book says differentiate, everybody say that with me. 1, 2, 3. Differentiate. How many syllables is that? Differentiate. That's a 5-syllabic, pentasyllabic monster there. Okay? Differentiate. So that means to find the derivative. Okay? Find the derivative. And if it says simplify your answer, then you have to go ahead and you have to gather like terms. Okay? It also means you don't have negative exponents in your answer. Okay? And the whole radicals in the denominator, that one's kind of, you don't have to rationalize the denominator always. That one's not as important anymore, like it used to be.
Wait, so we can have rationals?
You can have rationals in the irrationals in the denominator. Yeah, radicals. You can have radicals. Okay, so let's do number 2.
What do you mean by negative? Like we can't have negatives.
Let's do this one. Yeah, you should try, in a simplified answer, you should try to avoid negative exponents. Alright? Okay, so we're going to take the derivative of this and we're going to simplify. Ready? Y prime. Derivative of the first, which is what? Negative 2x to the negative 3. Everybody see that? Negative 2 comes down, you subtract 1 from negative 2. Times the second. Do not take the derivative of the second yet. So the derivative of the first, right here, times the second. Plus the first times the derivative of the second. So we got 3x squared minus what? 6x plus 0. You don't even need it. Okay, so that would be taking the derivative, not simplifying, you're done. But if it says simplify, now what you got to do is you have to expand, gather like terms, no negative exponents, all that sort of stuff. Okay, someone's happy about that. Okay, so we got to distribute this. See that? Distribute. So what is negative 2x to the negative 3 times x to the 3? No, you do not multiply exponents. Common base you add, so that's x to the 0, so that's just negative 2. Okay. What about the next one here? That's going to be plus 6, negative 2 times negative 3. And then what's negative 3 plus 2? X to the negative 1, right? Stop me if I'm doing something wrong here, because I'm trying to look at you guys too, see what you're thinking. And trying to deal with whatever's out in the hall there. Okay. Negative 2x to the negative 3. When I multiply over here, what do we get? Negative 12x to the negative 3. Good. Plus, now I multiply this out. So I get plus, what, 3x to the 0. So you can just, you don't even have to write that. That's just 3. And then minus 6x to the what? It's negative 2 plus 1. It's negative 1. Okay? Alright. So, are there any like terms that I can gather? Well, this is a like term because it has a variable and the exponent identical with this term. So those are like terms. And 6 minus 6, that's pretty handy. Those are gone. Right? And then negative 2 plus 3 is plus 1, right? So y prime equals, usually you write the variable term first. If there's a variable term and a constant, write that one first. And then what did I say? Plus 1. Okay. Now I have a negative exponent, so what I should do is not leave that as a negative exponent. That means that this thing goes down to the denominator like this. Not x3. No. cubed or to the power of 3? Not doing it. Don't say x3, please. That's a BMW car. Okay? The x3. Notice that's not x to the power of the 3 in the back of that car. It's just x3. Got that, boys? Whoa! What was that?